I've wanted to do space since I was a very small child. I grew up reading enormous amounts of science fiction, and that hasn't really stopped. So when I went to university, I wanted to carry on doing that, and I started with a physics degree. And then after physics, it was a little bit too pure for me, so I moved into engineering, aerospace engineering. And then after aerospace engineering, I ended up with a job in Matra in Toulouse, working on software for space simulations. And then after that, I moved into the UK to do thermal engineering of spacecraft. And I've been in spacecraft all the time since then. So I've spent 30 years working in space. So if I could tell my 8-year-old self that, he'd be very happy. Thales Alenia Space in the UK have had contributions to all 4 instruments. So we're the prime contractor for the Broadband Radiometer instrument. So all of these things involve casts of hundreds. So the Broadband Radiometer instrument, our role was to sort of coordinate the activities, define the design, make sure that the whole everybody's activities would align to make a successful instrument at the end. We also had we were supported in that by the Rutherford Appleton Laboratory, who made the optical unit for the BBR, and also ESR Limited in Warrington in the UK, who made the mechanisms, the motors. Also, all the software for our instrument was written by CGI, also near Bristol, which is where I'm from, in the UK. So my instrument was the Broadband Radiometer. Thales Alenia Space in the UK also built the computers for the ATLID instrument and the MSI instrument. And we also had a small part to play in the CPR instrument because we did a small mirror and a mechanism and the electronics to move that mirror. So we've got a finger in every instrument, let's say. I've been the lead engineer on BBR since we started the project in 2008. And my role has evolved throughout the time. So right at the start of the project, it was all basic design, deciding how to meet the difficult scientific requirements for the instrument, making decisions on whether to do it this way or that way, and then quite a lot of analysis to work out whether the thing you would eventually build would work. And then as that progressed throughout the development, you move on to building development models, and my job changed slightly to be more of again, trying to make sure that the results we were getting from the development models made sense in the context of the instrument. Also, as you translate something that's on paper into hardware, you get problems, and then you're always fixing problems all throughout the end. So yeah, my job has basically changed, and now it's a very different job. Now it's operations and processing of science data. All instruments, or most instruments, are based on historical things. Very few instruments come out of nowhere. So the BBR instrument was based on previous instruments that have flown called GERB. There was a series of instruments, Earth Radiation Budget Instruments. And in fact, Earth Radiation Budget Instruments, which our one is a type of, go back to the 60s, 1960s. They've been doing them for a very long time. Each time someone develops an Earth Radiation Budget instrument, it's a little bit better than the previous one, but I wouldn't say on this particular instrument that there were any dramatic innovations. It's a bit smaller, it's a bit more reliable, it's a bit more accurate. The main difference between this instrument and previous instruments is that the BBR is looking in 3 different directions at the same time, rather than just straight down at the Earth, which is unusual. The use of common electronics and software is desirable because, well, in the end, it makes it cheaper. But also, it means that you can reuse common elements, and it saves time and money in comparison to actually delivering things separately. It also makes sure that the spacecraft sees a common interface. So It can talk the same way. All the electronics units talk the same language to the spacecraft, which is very helpful. And also the software is not completely common. The core of the software, the boot software, was the same for all three instruments. But then the application software, because the instruments are slightly different, it's all slightly different, but based on a common framework. And there was quite a let's say, division between the European instruments and the Japanese instrument. It's mainly because it's a Japanese procurement. Well, like I said, we started in 2008. In fact, we delivered the instrument to the spacecraft in 2018, and the time difference between then and now is a story of political delays and not having rockets to launch it on and things like that. The difference between 2008 and 2018 is usually a story of developing something and things going wrong and having to recover what's gone wrong. Projects always seem to, whenever you're developing a new instrument, things take longer than you think because bad things happen that you didn't expect. And then you spend time trying to resolve those bad things. So, I mean, I could list a very large number of bad things, but they're all quite detailed and you might not want to hear them all. BBR has two mechanisms in it, and it relies on the use of these mechanisms to work. These mechanisms have to keep turning for the entire duration of the mission. And because one of them in particular has to turn quite quickly, it's like a bicycle wheel. It eventually wears out. So one of the things that can go wrong with the BBR instrument is the mechanism can wear out too quickly. Other things that can happen is all the instruments in the end rely on detectors, like a detector in a camera, like the camera is currently taking. And those detectors on cameras are quite sensitive to the environment that the spacecraft flies in particular the radiation environment. And so eventually radiation starts to damage the detectors, and bit by bit over life they start to die as well. BBR's detectors are quite large, so they're not really prone to that, but electronics generally suffers in the Earth orbit environment from radiation. Well, I'm a combination of nervous and excited and relieved to be here finally after 10 years of working on this project. More than that actually, 16 years of working on this. Fortunately, possibly, tonight is not up to me. I'm not the one with the finger on the button. But I'm surrounded by very skilled professionals who will make it work, and hopefully in a week or so's time, when they turn my instrument on, it'll all be good to go and we'll start getting back good data.